Alright, so the next problem we're going to work on is 5. And for problem number 5, we have f of x is equal to x minus natural log of x. And let's see, our bounds here are from x equals 1 to x is equal to 4. So x ranges from 1 to 4. Alright, so first step, we find the first derivative, which is 1 minus natural log, not natural log, 1 minus 1 over x. Right, so derivative of x gives 1, and derivative of natural log of x gives 1 over x. Alright, so now we need to square this. So let's see here, f prime of x squared is equal to 1 minus 1 over x squared. Alright, so we can write this as x minus 1 divided by x squared, and this would come out to be x minus 1 squared divided by x squared. And let's see here. Now we just need to add 1 to this, so we're going to have 1 plus f prime of x squared is equal to 1 plus x minus 1 over x all squared. Alright, so I think we might be able to simplify this one. Right, so we can write this as x squared plus x minus 1 squared all over x squared. Right, and all we've done is simply multiplied the 1 over here by x squared over x squared and then combine the two fractions. So now we can simplify this a little bit more. We have x squared plus x squared minus 2x plus 1 divided by x squared. And let's see if we can maybe, let's see, 2x squared minus 2x plus 1 divided by x squared. So it's looking like this might not actually simplify it. Let's see, 2x squared minus 2x plus 1 over x squared. So this won't simplify it. So we can leave it the first way that we had it, which is 1 plus x minus 1 over x all squared. Alright, so now let's see here. So we're going to write s is equal to the integral from 1 to 4 a square root of 1 plus x minus 1 divided by x all squared times dx. Okay, and this is something we're going to have to plug this one also in the calculator to get the bounds. So let's do that. And that gives us 3.45. Okay, next problem is problem number 6. Alright, so problem number 6. We have f of x is equal to, well, actually with problem number 6 we have x equals y squared minus 2y, so this is going to be f of y. Right, we have x as a function of y, so this is going to be f of y is equal to y squared minus 2y, and your y values range from 0 to 2. So we're going to write y ranging from 0 to 2. So again, we take our first derivative with respect to y, and we get 2y minus 2, and then we square our f of y. So we have 2y minus 2 squared. And let's see here. We'll just leave it like this. We're not going to expand it this time, just so it makes the integral look a little bit cleaner. So once we take the derivative, we square it. Now we plug it into the formula. So s is equal to the integral from 0 to 2 of the square root of 1 plus 2y minus 2 squared. And this time, instead of writing dx, we'll just write dy because we're integrating everything with respect to the y variable, not the x variable. Okay, and let's see what this integral comes out to be. Okay, so this one comes out to be 2.958. Okay, so let's work on the next one. Alright, so next problem is problem number 7. And for problem number 7, we have another function of y. So we're going to write f of y is square root of y minus y. So let's go ahead and write square root of y minus y. And our y value ranges from 1 to 4. Okay, so our first derivative, which is f prime of y, right? So square root of y, we can write square root of y as y to the power of 1/2, right? So that when we take the first derivative, we can just apply the power rule. So we bring down the exponent as a coefficient, and then we reduce the power by 1. So instead of y to the power of 1/2, we'd have 1/2 y to the negative 1/2. Derivative of negative y is just negative 1. And now we can square this. And then place it in the integral and solve. Alright, so that means our arc length is the integral from 1 to 4 of square root of 1 plus 1/2 y to the negative 1 to the negative 1/2 minus 1 squared dy. Okay, so this result comes out to be 2.36. Alright, so that takes care of the problems for this one. The next set of problems we're going to work on, actually, we're going to focus more on carrying out the integral process. In this set of examples, all we had to do was just set the integral up, plug it into the calculator, and figure out what number it comes out to be, right? So the arc lengths for each one of these functions, we just apply the arc length formula. You identify the bounds of integration, the a and the b, right? The a and the b. And it's just a matter of properly differentiating your function to get the f prime, squaring it, adding 1, taking the square root, and then in this case, plugging it into your calculator to get a result.